Okay, so this is a demonstration of my 4th year project. It's a 3D race game, so as you can see on the scene, I have just a simple straight track setup with a few objects to move around. I have 2 race cars, one for the player, one for the computer, and we'll go through the one for the player first. So I have a Python script here which basically controls movement, acceleration, and rotation. After setting up the keys, I create a variable called n and assign it a value of negative 0.1. The reason it's negative is because we want the car to move forward. If we wanted it to move backward, we would assign it a value of positive 0.1. So next I have a few if and else statements. So these basically tell the race car what to do when certain keys are pressed. So if we press the X key, we want the speed to increase by 1. If we press the W key, then we want the car to move at n speed in the direction of the object's local y axis. So as you can see, we have 3 parameters, x, y, and z. So we want it to move on the local y axis, so we put in n for the y parameter, and we set it to true because we want it to move on the object's local y axis. We wanted it to move on, say, the global y axis, in other words, on the axis in relation to the world as opposed to in relation of the object. We would set that to false. Then we have an elif statement next that says elif the S key is pressed. We want the car to move backwards, so it'll move backwards at a speed of 0.1 again on the local y axis. And then the A key and the D key are used for rotation, i.e. turning the object left and right. So if the A key is pressed, we want the car to move 0.1 units on the Z axis of in relation to the object's local axis. And similarly, if we want it to move right, we'll make it negative 0.1. So positive will make it move left, turn left. Negative will make it turn right. Moving on to collision then. Collision works by setting the physics type to dynamic. The reason we set it to dynamic is to allow it to detect collision. If we don't set it to dynamic, it won't be able to detect collision. And then we make it an actor. So that it can interact with the world. We lock translation on the y-axis to keep it from changing its position in terms of keeping it flat on the surface, basically, is what that does. Collision bounds, then we make a convex hull to ensure that the entire shape of the object is used for collision. So that some of the object doesn't go through things, basically. And we turn the margin right up to 1 in order to ensure that the car collides with everything and doesn't go through anything. So after this, all it's left to do is add the Python script to the race car. So we do this by selecting the race car, adding an always sensor to the race car. The always sensor is basically means do this for as long as the game is running. Then we add a controller up to Python, a Python controller, and we just assign it the Python script. So I run that much. Anyway, I'll show you it moving and colliding. So the red car is the player's race car. So as you can see, it's moving forward. I turn it left, collide with the wall, turn right. It can also reverse, and then if I hold X, it'll speed up. Okay, moving on to the computer's race car. So, the computer's race car consists of the actual race car object and simple plane axis rotated at a 45-degree angle so that I can place a radar sensor on it, and that the radar detects at a 45-degree angle any oncoming collisions. So just to ensure that it has a good enough span to detect everything. So in order to make this work, we have a few things. We have an always sensor. So this row, the top row of blocks, we want the actuator to activate for as long as the race car is running. We have an AND controller connecting them. So like the AND controller basically says, make sure every sensor connected to this AND controller is positive. In other words, it's doing all these things before it does this. So the always sensor is going to say always do this for as long as the game's running, and this actuator basically just tells the car to move forward at 0.10 speed on the y-axis. It's a simple motion actuator that just means basically just move. So that's just to make the race car move forward. That's all that does. The next two rows, we have a radar sensor. So we have two radar sensors, one for the left, one for the right. This is the one for the left. So since this is the left, we want it to detect oncoming collisions on the plus y-axis. And if it detects a collision on the plus y-axis, we want the race car to turn -5 units on the z-axis. Similarly, for the right, we put this on the plus x-axis. So if it detects a collision on the plus x-axis, we want it to move +5 units to the right. So I'll just show you doing that. So you can see the two kind of grids in front of the race car. They're the radar sensors, and we'll see if it'll avoid this wall. So you see it avoided and it goes around it. So that's how that works. So I also have a camera set up so that to enable camera tracking, so that the player can follow the car from behind. So that's basically it. for the most part. Thanks for watching.